a quick review of where we left off. We started looking at something special called the binomial distribution, and we're gonna show when you can use this. But we started out saying, hey, how could you figure out the probability of guessing if you were rolling a dice 3 times, guessing exactly 2 of them correctly? And we noticed there was a way to set it up with combinatorics. We said, okay, if you're rolling 3 times and you want to guess 2 correctly, it was from 3 rolls, choose 2 correct. What were the odds of guessing correct on any one roll? 1 out of 6. 2 of those. What were the odds of guessing wrong? 5 out of 6 to the exponent of 1 of those. We said this was the pattern that we noticed, that we derived. So we started looking at, for example, the probability of guessing 4 correct in 6 rolls. It would be from 6 rolls, choose 4 correct. What's the probability of guessing correct on a dice? 1 out of 6 to the 4th. What's the probability of guessing wrong on a die? 5 out of 6, I want to get 2 wrong. And we said your clue that we wanted to use some kind of a combinatorics approach was, I don't want to do a 6-level tree. That would be, I think, 36 branches on the bottom. That'd take up an entire page because we're rolling 6 times. We said, you know what? As long as the odds don't change from one roll to another, like dice, we can use this for other things as well. We said you could use it for coins. Now, the only problem is a real coin is 50-50, which is boring. You keep getting the same answers over and over and over. So I made up this biased coin. I said, okay, let's suppose you have a rigged coin and there's a 70% chance that it comes up heads. What's the probability that you get that you guess 4 correct? Well, we said from 4 guesses, choose 4 correct. There's a 0.7% chance of getting it correct once. To the 4th, I want 4 of those. There's a 0.3%, a 30% chance of getting it wrong. I want none of those. This was the pattern that we were looking at, and we said we're going to pause here. So B. A fair coin is flipped 12 times. How many times? 12. Do I want to do a 12-level tree? No. No. Now, this is either a bucket or today's lesson. The way you can tell it's today's lesson and not a bucket is the odds never change. If the odds change, then you want to do a bucket. And what I mean by that is for card questions, the reason we use buckets for card questions is, suppose the event is getting a spade. Once I've picked a card, if I have a spade, how many spades are now left in the deck? 12. And if I get another spade, how many spades are now left in the deck? 11. The odds are changing. That's bucket. That's combinatorics. But if the odds don't change ever, like rolling a die, the odds are always 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6. Or flipping a coin, the odds are always 1/2, 1/2, 1/2, 1/2. Then we can use this method. So it's going to look like this. If I want to calculate the probability of exactly 6 right in 12 flips, or 6 heads in 12 flips. Oh, you're eating. I thought you were phoning. I was going to freak. Okay. Sean, how many flips grand total? It's going to look like this. Right with me. 12. Choose. Sean, how many do I want to get correct? Or in this case, how many heads do I want?
6.
What's the probability of getting heads on any one roll? On any one flip of a coin. If you flip a coin, what's the probability you're going to get heads? I can't. Don't overcomplicate it. Flipping any coin, a normal coin, what's the probability you get heads?
1/2.
Yes. How many heads do I want to get?
6.
What's the probability of getting a tails? 1/2. How many tails do I want to get if I want 6 heads and I'm rolling it 12 times?
6.
Okay, this is why in the previous example I gave you a biased coin, because the 1/2 and the 1/2, because it's the same number, to me, Jordan, makes it kind of confusing because people don't realize that's how many wins or successes or heads or correct. That's failures. Anyways, crunch that, please, on your graphing calculators. If you flip a coin 12 times, what's the odds that you get exactly 6 heads, no more, no less? Option prob 12, choose 6, bracket 1/2. Oh, that didn't work. Half to the power 6. Oh, I think I have to put a times here, don't I? I think I went through this last time. I'm used to my other graphing calculator. Bracket 1/2 to the 6th. You get 0.2256. What about getting exactly 2 heads in 12 flips? First of all, if you flip a coin 12 times, do you think it's more likely that you get 6 heads, or do you think it's more likely that you get exactly 2 heads? And convince me, give me an argument. Is someone back there missing a calculator?
No, I'm trying to help her find, but also I'm making myself.
By the way, it looks like for some reason this decimal, there we go. Sorry, that's what it should be. The decimal didn't show up. Exactly 2 heads in 12 flips, it would look like this. How many flips? 12. Choose. There's the probability of getting a heads once. How many heads do we want to get? 2. Whoever's clicking the pen, can you stop? Thank you. There's the probability of getting a tails. How many tails do we want to get? 10? Good. Crunch that. What do you get? What's the probability of getting exactly 2 heads? I think I can just backspace and edit if I'm clever. I think I can go put a 10 there. Put a 2 there. Put a 2 there. From 12 flips, choose 2 successes, 2 heads. 1/2 to the 2, 1/2 to the 10. And as a decimal, 0.0161. Which is smaller than our previous answer, which at least Jacob makes me think maybe I typed it in correctly, I hope. Okay. I wrote down here, write an expression for getting X heads in 12 flips of a fair coin. It would look like this. From 12 flips, choose you want X heads. There's the probability of getting a heads once. You want X of them. There's the probability of getting a tails. You want whatever number, the opposite of it, 12 minus X of them there. Coins are boring. Tests are more interesting. Sorry, some used to writing that down. Right, 12 choose however many successes, probability of success to the power of however many successes, probability of the opposite to the power of however many failures. Hey, let's look at actually a multiple choice test. This is something probably you've kind of wondered. So multiple choice test has 10 questions. How many questions? 10. Each question has 5 choices, only one of which is correct. So what's the odds of guessing correctly on one question? What's the probability of guessing correctly on one question if there's 5 answers to pick from? 1 in 5. 20%, 1 in 5. We'll use 1 in 5. Determine the probability of each of the following events if you randomly guess. So in 10 questions, what's the probability you get exactly 2 correct? How many questions? Choose. How many do we want to get correct, Jacob?
2.
What's the probability of guessing 1 question correctly? What did you say? 1 out of 5. How many do I want to get correct?
2.
What's the probability of guessing wrong? 4 out of 5, the complement. And if I get 2 correct out of 10, how many must I get wrong?
8.
Okay, suppose you're guessing on a test. It's 10 questions, it's multiple choice. What's the probability that you get 2 out of 10? 10, choose 2 times 1/5 to the 2 times 4/5 to the 8 0.302. Yes? B. What's the difference between A and B? What does at least 2 mean? 2 or? Okay, I could go calculate for 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, where or means at. Can anybody see a better way to do this? Tiff. You know what? This means 2 or more, which is the same as 1 minus the probability of 1 or 0. I could go 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, but the faster way would be to go 1 minus 1 or 0. I'll get because all of them got to add to 1. Use the complement. You okay with that, Christina? That's going to be way faster. So it's going to be, let's see, 1 minus. So if I want to get 1 or 0, there's going to be a plus sign here. 1, that's going to be from 10, choose 1, 1/5 to the 1, 4/5, 9 of them. None right would be 10, choose 0, 1/5 to the 0, 4/5 to the 10. Let's use square brackets to kind of distinguish a little bit. Is that right, I think? Yeah? I'll do what's inside the brackets first. I'll hit equals, and then I'll go 1 minus, use my answer button. So I'm going to go like this. 10, choose 1 times 1/5 to the 1. I probably didn't really need to type that. Times 4/5 to the 9. Or 10, choose 1 times 1/5 to the 0, 4/5 to the 10. So that, I think, is what's inside the brackets. Let me double check. Does that look right? Ah, the second one is 10, choose 0. Thank you. Kind of convenient the way it all lined up like that, actually, vertically. And then 1 minus, my answer button, remember, is right here. It's second function negative, right down there. Second function negative. You know what? There's a 62% chance, there's a 0.6242% chance, there's a 0.62 0.42, or 62.4% chance that you get at least 2 right. Of course, Sean, that's not the question that you'd be interested in. If you're guessing on a test, you don't want to know getting at least 2 right. What do you really want to know? What's the probability that you'll what? Pass. What would passing here be if there's 10 questions? 5 or 6 or 10, or I could go 1 minus 4 or 3 or 2 or 1 or 0. All of those are going to take a long time. That's an interesting question. That's the question I want to know. Right now, that's too much work. There's got to be a shortcut, and there is. I wrote down for part C here, obtaining exactly X correct answers. You know what? I'm actually just going to say, instead, if there's 10 questions and you're guessing randomly, what's the probability you get perfect? Colin, what am I going to write here? It's going to be from 10 questions, choose. Getting perfect means how many do I want to get right? Oh. What's the odds of getting 1 right? How many of those do I want? 10. What's the odds of getting 1 question wrong? That didn't work very well. Let's try that again. How many wrong do I want to get? How many wrong do I want to get here? Okay. If you randomly guess, what's the probability that you get perfect? I think it's going to be a small number. 10, choose 10. 1/5 to the 10. And I think anything to the 0 power is just 1. 4 over 5 to the 0 is just 1. It's not going to change my answer. Well, there is a 1 in, almost a 1 in 10 million chance of getting perfect. As a decimal, 1.04024, so boy, 1.024 times 10 to the negative 7, which is 0.1234567. What do 3 dots mean? Therefore, study. Sorry, but the probability of getting perfect is pretty slim. Let's put this all together. So the questions that we've been doing can be thought of as binomial experiments. Now, a binomial experiment, the prefix bi means 2, bicycle, 2 wheels. A binomial experiment has 2 outcomes: success or failure, heads or tails, yes or no, in or out, sunny or not, success or failure. 2 outcomes, and the odds don't change. The odds don't change. So a binomial experiment consists of a fixed number of independent which means the odds don't change, the probability doesn't change. Dice, 1 out of 6, it's always 1 out of 6, it's always 1 out of 6, it's always 1 out of 6. Coin, it's always a half, a half, a half, a half, a half, a half, a half. This test that we just did, on each question, the odds were still always 1 out of 5, 1 out of 5, 1 out of 5, 1 out of 5, 1 out of 5. Okay? And only 2 possible outcomes: success or failure, yes or no, right or wrong, heads or tails, guessing the dice correct or not. And as an equation, it looks like the probability of X number of successes of, for example, the probability of getting 2 correct, that would be the probability of 2, is the total number of trials, n, choose X number of successes. P is the probability of success to the power of X. Q is the probability of failure or getting it wrong, or the complement to the power of whatever's left, however many wrong, the complement number of how many right. And I put as an important note here, because kids always go binomial loopy, card questions are not binomial because the odds change each time a card is chosen. Oh, unless each time you're picking a card, you're putting it back in. That's boring. You with me? Okay. Turns out our graphing calculators have this built in. So I have given you this formula in the red box. It is on your, is your formula sheet pink in this unit or yellow? I can't. Pink? It is on your pink formula sheet. But it also turns out that your graphing calculators, all of you are going to get out your graphing calculators. Your graphing calculators have this built in. Okay? If you go menu, and we need to go to a whole new menu now. Psst, need to pay attention here. So menu, and then go to the stat menu, which is option number what? 2. And then this is a binomial probability distribution. So I want to hit the distribution, which is F what? F5? What kind of a distribution is this? A binomial, oh, you know what? F5 again. And then it has 2 subtypes. We'll talk about what these 2 mean, but this first one is a binomial probability distribution. That's what BPD stands for, which is F1. And then it wants to know, do you want to use a list of data or are you going to use variables? We would use a list if we were actually doing an experiment and we typed in a whole bunch of data. Have we typed in a whole bunch of data? No, you know what? We're always going to be using variables. And you can see it's got the same setup. It says X equals num trial is the number of trials, and P is the probability of success. So I wrote down here, let's try a previous example using our calculators. So example 3, a multiple choice test has 10 questions. Each question has 5 choices. Determine the probability. So we already did exactly 2 correct, but we did it using the formula. We said exactly 2 correct was 10 choose 2, 1/5 to the 2, 4/5 to the 8. Now let's use our graphing calculator software. So if I want exactly 2 correct, I scroll down to this. How many correct do I want to get? 2. So I put a 2 in for X. How many trials are there? How many questions are there grand total? Put a 10 there. What's the probability of getting 1 question correct by guessing? 1 over, you can either go 1 divided by 5 or 1 fraction 5. Enter. And then I scroll down to highlight execute. And what does it say by F1? Calc. And I think that's the same answer as we had before. I think if, so you guys got that on your calculator. I'll scroll back. Before we also got 0.302. Yes? I would argue in some ways this helps you figure out where the numbers go and how they relate. This is way faster. Now, if you use your graphing calculator, I will not accept it if you just write an answer. What I will, if you're going to use your graphing calculator, what you will need to show me is these 3 values here. So where it says obtaining exactly 2 correct answers, I would need you to write in terms of showing work, X equals 2, num trial equal 10, P equals 1/5, and then you could just say the answer, 0.302. I won't just let you, Jordan, write down the answer. You got to somehow, because that way if you get it wrong, I can try and compare typing in the numbers and see what you did. B. So use your graphing calculator to find the probability of getting exactly 5 correct, which would pass. Well, in this case, what does X equal? 5. Number of trial is still 10. P is still 1/5. You know what? This is pretty quick. I can actually just go 5. And the probability of getting 5 right is 0.0264. 0.0264. Or about 2.5%, 2.6% chance of getting 5 right. So far, so good? Now we can start, because we got our graphing calculator going, now, Brooke, we can start to answer the question that's more interesting, the question that says, what's the probability of passing? So suppose I want to know the probability of passing this test. This would require us to calculate the binomial probability distribution, the BPD, of 5 or 6 or what? 7 or 8 or, which I could do. Yuck, that's a lot of work, Ellen. Maybe there's a shortcut. Well, if you go exit and exit again and then go dist binom, so exit twice to get back to this menu. Once again, go back into the distribution and back into the binom. This second one says BCD. The first one says BPD, which stands for binomial probability distribution. The second one, BCD, stands for binary cumulative distribution. What does the word cumulative mean? As an example, I grade you guys cumulatively. I don't grade term by term. What does cumulative mean? It adds up. What this one does is, so let's press it, which is F2. Okay? And I think yours should still say 5, 10, and 0.2. If you, we're not going to hit enter, this would add up 5 or 4 or 3 or 2 or 1 or 0. It always adds up below. This would add up 5 or 4 or 3 or 2 or 1 or 0. So we can use that. So BCD, which stands for binomial cumulative distribution. If you go BCD, and it still says up here BC, so I can double check. If you go where x equals 2, the number of trials is 10, and p is 0.2, and you go to execute calculate, this adds up the probability of getting none right, 1 right, or 2 right. The odds of getting, the probability of getting 2 or less is 0.67779995. That is that. What if instead of x equals 2, what if x equals 4 and I'm using BCD? What would that add up? What would that add up? If I put a 4 here, what would that add up? First of all, what number did I put there? 4, so I'll give you a hint. 4 or 3 or 2 or 1 or 0. Now, it always goes down. We can't change that. It'd be nice sometimes if it would go up instead. No, the BCD is programmed to take that number and everything below it. So we calculate the probability of 4 or 3 or 2 or 1 or 0. Now, why does... Oh, by the way, can you calculate that, please? Can you find the BCD, the binomial cumulative distribution of 4 or less? And I get 0.9672. Yes? If we know the probability of getting 4 or less correct, How can that help us figure out the probability of passing? Ellen, what? Okay. Probability of passing is probability of 5 or more, yes? Which is the same as 1 take away the probability of 4 or less. This is going to help us answer now some cool questions. Which is the same as 1 take away the BCD of 4, 10, and 1 out of 5. Let me make that a little longer so it's all on one line. So have you all typed in this and you have this here? Now the nice thing is that there is now also stored into our answer feature, our answer function. So I want to go 1 minus the BCD of 4 or less. Dope. Come on. Which is 1 minus 0.96720, 0.9672065. To get to my minusing, I have to go menu and back to run, option 1. Because now I can actually do the minus. But here's the nice thing, Jake. I believe that number, that 0.9672, is stored in my answer. If I go 1 minus answer button, there it is. Is that right, Mr. Dueck? Hang on, I got to double check that. Let me take that back. Maybe it doesn't. I was playing around with this. BCD. Okay, it's that. Menu 1. Nope, I stand corrected. I think it might on yours. I don't know if it does on my computer calculator. I think it might on yours, but I have to do this by hand, so I have to go 1 take away 0.9672065. The probability of passing is that. 0.328. You guys can go 1 minus answer button? Yeah, I can't. Nope. Okay. So let's try a bunch more here. Next page. Provincial exams, part of which are multiple choice. A provincial exam has 25 multiple choice questions. Each question has 4 possible answers. So what's the odds of guessing one question correctly if there's 4 possible answers? 1/4 or 0.25? Okay. Find the probability of getting exactly 5 questions correct. That's going to be the BPD. 5 correct, 25, 1/5. If you're looking for a shorter way to list things, I'll accept that as well if you just put them in order. Or you can write x equals 5, num trial equals 25, p equals 1/4. I said 1/5. 1/4, Mr. Dueck. 1/4, Mr. Dueck. 1/4. Sorry, guys. Okay. I'll take either of those versions to write. You can either just write all three in brackets in the order that they appear on your screen, or you can list them all. I don't care which. Anyways, what's the answer? Is this cumulative, or are we just finding one single value? So I want to use the binomial probability distribution, not the cumulative. I want to use the F1. 5, 25, a quarter, or 0.25. Do you get 0.1645? How many questions were there grand total? 25. Doing this with a tree would be 25 levels. Blech. B. Find the probability of getting at most 5 questions. What does at most 5 questions mean? Five or less. You know what? 5 or less, that's a job for the binomial cumulative, the BCD, the cumulative distribution, where I go 5, 25, and 1/4. Exit twice, distribution again, binomial again, cumulative. 5 or less, so getting 5 or 4 or 3 or 2 or 1 or 0 is 0.3783. C. Find the probability of getting less than 5 questions correct. What does less than 5 mean? 4 or less? That means 4 or 3 or 2 or 1 or 0. This is also a job for the binomial cumulative distribution, except what number do I want to put in for x? 4. Still 25 questions. Still 1 in 4 chance of getting any one correct. I'm still in the binomial cumulative. There's a C there, so I don't need to back all the way out. I can just put a 4 there. Oh, you know what? The probability of getting 4 or less is 0.2137. D says, find the probability of getting exactly 13 questions correct. Does this want me to find 13 or 12 or 11 or 10, or does it just want me to find only 13? Okay, only 13 is going to be BP, the binomial probability distribution, where x is 13, still 25 questions, 1 in 4 chance of getting correct. I'm going to have to backspace out, exit, exit, distribution, binomial BPD, where x is 13, 25 questions. Oh, the other one's already there still. Good. I'm getting an answer in scientific notation, 2.45 times 10 to the negative 3. 2.45, Mr. Dueck. Which is 0.00245. Getting 13 right, which is passing, because 12 would still be a fail out of 25. Not very high, and that's 13. You know what? I want to find out the probability of actually passing, which means not only 13, but what else? 13 right, or 14, or 15, or 16. You know what? There's a better way to do this, using the complement. The probability of passing is going to be 1 minus the probability of what? Yeah, but more specific. Kyle, sorry, Erica. 12 or less. Which is going to be 1 minus, since you said or less, that's exactly what the BCD was designed for, where I put a 12, 25 questions, 1 in 4. 1 minus, so I'm going to, first of all, move this over a little bit. Exit, exit, distribution, binomial, cumulative. I want 12 or less. I get 0.99663. Is that right, Mr. Dueck? Yep. So now I need to actually do the subtraction. I need to go to my run menu. 1 minus 0.99663. And I get 3.37 times 10 to the negative 3. Which is 0.00337. Study. Hey, what's the probability of failing this test by randomly guessing? What is failing in this case? Out of 25, how would you fail? 12 or? Oh, you know what? That's just going to be 12 or less. That's just going to be the cumulative distribution of 12, 25, and 1/4, which I already figured out on the previous question is 0.99663. The probability that you're going to fail is 99.7% if you randomly guess. Is that a hand up, Rosanna? Okay. The last question, suppose you guess on all 25, what's the probability of getting perfect? It should be very small. Getting perfect would be what? How many right? 25. Is this a cumulative or just a single solitary? Okay, so I don't want the BCD. I'm going to have to dist, binomial. I want the BPD of 25. Oh, wait a minute, Mr. Dueck, you got to show work. This is going to be probability of exactly 25, which is the binomial probability distribution, the P, not the C, of 25, 25, 8.88 times 10 to the negative 16. 8.88 times 10 to the negative 16, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 8, 8, 8. Are you going to get a scholarship by randomly guessing? No. Never going to happen. Those odds are near zero. Almost. Okay. By the way, what if instead of doing BPD, what if I did the binomial cumulative distribution for 25 questions? What should the answer to that be? If it's 25 or 24 or 23 or 20, all the way down to 0. What should those all add to? Jordan. They should all add to, oh, yeah, that's every possibility, and my calculator does clue in when it adds them all up. But yeah, the answer is 1. So that's every possibility. Okay? What's your homework? I have a lesson 7 homework. You'll have also class on Wednesday to work on it. On Wednesday, I'm also going to be giving you a take-home quiz. Wednesday is Get Caught Up on Everything Day.